Hello guys, in this video we will be looking at one example where we need to find the four moments as well as the Pearson beta and gamma coefficients. So find four moments and beta comma gamma coefficients. So they have provided us with the observation table, that is x and frequency. For 0 frequency is 1, for 1 frequency is 8, for 2 frequency is 28, for 3 frequency is 56, for 4 frequency is 70, for 5 frequency is 56, for 6 frequency is 28, for 7 frequency is 8, for 8 frequency is 1. So this is the entire distribution table they have provided to us. We have to find the four moments as well as the beta and gamma coefficients. So before we do any problem in these moments as well as beta and gamma coefficients, kindly note down all the formulas which are required to solve this problem. So writing four moments, that is u1 is equal to, u1 is always 0, so don't worry about that, and u2 is equal to u2 dash minus u1 dash square. So u3 so mu3 is equal to u3 dash minus 3 mu2 dash mu1 dash plus 2 mu1 power 3 mu1 dash power 3. So mu4 is equal to mu4 dash minus 4 mu3 dash mu1 dash plus 6 mu2 dash minus mu1 dash square minus 3 mu1 dash power 4. So these are the four moments. So these are the four moments we have to find, and we should also find the beta and gamma coefficients, that's Pearson beta and gamma coefficients, beta and gamma. So beta 1 is equal to mu3 square by mu2 cube, and gamma 1 is equal to root of beta 1, and beta 2 is equal to mu4 mu2 square. Gamma 2 is equal to, we have to subtract 3 from beta 2. So these are the formulas we need to find the solution for the given problem. So coming to the moments, so moments u0 is already 0, so we don't need to find that. For coming to mu2, we have to find mu2 dash and mu1 dash. So we don't know what is arbitrary points value, so write all the formulas of arbitrary value also, and later we can write all the values in the frequency table. So writing arbitrary formulas, that is for u11 it is 1 by n sigma ft. So if you don't remember the arbitrary points, just watch my previous video. I have explained all the arbitrary values, mean values, as well as the relation between the arbitrary and the mean. So mu2 dash is equal to 1 by n sigma ft square, mu3 dash is equal to 1 by n sigma ft power 3, mu4 dash is equal to 1 by n sigma ft power 4. So from all this formula, what is the requirement for us? We have to find the fd value, fd square value, fd power 3 value, fd power 4 value to compute mu1 dash, mu2 dash, mu3 dash, mu4 dash respectively, and we have to substitute in the moments to get the result of mu1, mu2, mu3, mu4, and later we have to find the beta and gamma coefficients. So this is the entire. So we have written all the formulas required as well as the requirement to solve this problem. So let me draw the frequency distribution table to calculate the moments. X as well as the frequency we know. So x they have provided us from 0 to 8, 0, 1, 2, 3, 4, 5, 6, 7, 8, and the frequency is 1, 8, 28, 56, 70, 56, 28, 8, 1. So these are the frequency. So from the observation we can calculate that we can calculate n value. N is nothing but the sum of frequencies. N is equal to, so we need to calculate the sum of the frequencies to get n value. So frequency is 1 plus 8 plus 28 plus 56 plus 56 plus 70 plus 56 plus 28 plus 8 plus 1. So our total frequency is 256. So n is sigma n is 256. So keep it as right. So what is the requirement to do to calculate u1 dash 1 by n? We know f frequency we know, but we don't know the d value. D value is calculated as d is nothing but the deviation value, that is, so in moments d value is not the x minus a by h. Here in moments h value is negligible, that is we can see that 0 or 1. It is so the it is 1, so that is not much calculable. So our d value will be x minus a. So what is a? A is an arbitrary point. So you can consider any of the point in the frequency in the x values. So mostly we will be considering the mid value. So I'm also taking the mid value. So remove 4 from bottom, remove 4 from bottom. So here arbitrary point is 4. So if you remember the simple trick, in front of 4, that is here, place 0, and before zeros all will be negative, minus 1, minus 2, minus 3, minus 4, and after zeros it will be plus 1, plus 2, plus 3, plus 4. If you don't remember the trick, I'll try to, if you have time, just do it. What is x value? X value is 0. 0 minus what is arbitrary point value? 4. Minus 4, minus 4. So next arbitrary point is 1. So 1. Sorry. What is you have x1 minus 4 minus 3. So that is the way you can get the values of d can get the d values. Now we have to find fd, fd square, fd power 3, fd power 4 to calculate mu1, mu2, mu3, mu4 respectively. So let us do that. So we need 4 columns: fd, fd square, fd power 3, and fd power 4. So these are the requirement from the requirement for the problem to solve. So let us calculate fd first. F into d, minus 4, 8 into minus 3, minus 24, 28 into 2, minus 56, 56 into 1, minus 56, 70 into 0, 0, 56 into 1, 56, 22, 28 into 2, 56, 8 3s are 24, 4 1s are 4. So let us sum up all the fd values to find sigma fd. So you can see that from the table, minus 4, minus 4, minus 24, minus 56, minus 56, plus 56, plus 56, plus 24, 4. We can clearly see that from the given table we can find that sigma fd is 0 and fd square. So let us find fd square. So you can use your calculator, both are variables. So I will be using these values. Y should be a square. So let's calculate. F is 1 for and y is minus 4, which is 16. So next we are calculating for 8 and minus 3. So x is 8 and y is minus 3. So we got 72. Next x is 28 and y is minus 2. We got 112. Next x is 56 and next we divide as minus 1 is 56, and here we'll directly get 0, and here 56 1. So calc 56 into 1, 56. So 28 into x is 28 and y is 2, will be getting 112, and 8 into 3 will be getting 72 itself, and 1 into 4 will be getting 16. So 72 as well as 16. So let us sum up this fd square. Sigma fd square is equal to, so 16 plus 72 plus 112 plus 56 plus 56 plus 112 plus 72 plus 16. So total we got as 512. 512 is this sum of the frequency of fd square. So let us calculate fd power 3 also. So both are variables. So x into y power 3. So let me take the x1. So x is 1, y is minus 4. So x is 1 and y is minus 4. We got 6 minus 64. And next one 8 as well as minus 3. We'll be getting minus 216. Next minus 28 as well as minus 2. We got minus 224. Next it is 56 and 1. We'll be getting 56 and it is 0 plus 0. And from the below it is nothing but the positive one. It should be negative 56 and write all the values. 56, 224, 216, 64. So these are the same values we are going to take. So that's why I wrote simply. So let us sum up all these values. So you can see that 64 to minus 64 minus 216 minus 224 minus 56 plus positive of all the values above results to 0. So sigma fd power 3 is 0. So let us solve for fd power 4. So fd power 4, take the values x into alpha by power 4. So let us calculate. So f is 1 and x is minus 4. We will be getting 256. So next one 8 and minus 3. 8 minus 3, 648. Next 28 minus 2, 448. Next 56. Sorry, 56 and minus 1 is 56. So remaining 0 and write all the values based on the previous one, that is 56, 448, 648 and 256. So let us sum up all the FD squares. 256 plus 648 plus 448 plus 56 plus 56 plus 448 plus 648 plus 256. So which results to sigma fd square is equal to sigma fd power 4 is equal to 2816. So we have got all the values which are required to solve our problems. Just note them beside. Sigma fd is equal to 0. Sigma fd square is equal to 512. Sigma fd power cube fd power 3 is equal to 0. Sigma fd 4 is equal to 2816. So these are the values we have noted and is equal to 256. Values we have got from the table. So let us find the moments, that is arbitrary values. The mu1 dash is equal to 1 by n sigma fd. Mu1 mu2 dash is equal to 1 by n sigma fd square. Mu3 dash is equal to 1 by n sigma fd power 3. Mu4 dash is equal to 1 by n sigma fd power 4. So 1 by n is 1 by 256. What is sigma fd? Sigma fd is 0. So mu1 dash is equal to 0. Next mu2 dash 1 by n is 1 by 256 into we got fd square is as fd square is 512, which results to mu2 dash is equal to 2. So 6 ones are, this is 2's are. Next mu3 dash 1 by n, 1 by 256 into FD power 3. FD power 3 value we got as 0, so 0, which results to mu3 dash is equal to 0. Next mu4 dash, mu4 dash 1 is nothing but 1 by 256 of sigma FD power 4 is 2816. So let's just do that. 2816 divided by 256 is equal to 11. So mu4 dash is equal to 11. So these are the arbitrary points we got. Let us substitute all these arbitrary points in the relation between the mean and in the moments to get moments. So mu0, mu1 is always 0. So mu2 is equal to mu2 dash minus mu1 mu1 dash square mu2 dash. So are able to see the screens right? So what is mu2 dash? Mu2 dash is 2. 2 minus mu1 dash. Mu1 dash is 0. So it will be 0 square is 0. So mu2 is equal to 0. 1. So now calculating mu3. Mu3 is nothing but mu3 dash minus 3 mu2 dash mu1 dash plus 2 mu1 dash square. What is mu3 dash? Mu3 dash is 0 minus 3 of mu2 dash. Mu2 dash is 2, mu1 dash is 0 plus 2 of mu1 dash is 0 square, which results to 0. So mu3 is also 0. So let us find mu4. Mu4 is equal to mu4 dash minus 4 mu3 dash mu1 dash plus 6 mu2 dash mu1 dash square minus 3 mu1 dash power 4. So what is mu4 dash? Mu4 dash is 11. 11 minus 4 of what is mu3 dash? Mu3 dash is 0. Mu1 dash is 0 plus 6 of mu2 dash, 6 of 2. What is mu1 dash is 0 minus 3 of 3 mu1 dash is 0. So which results to this will be 0, this will be 0 and this will be 0. So we will be getting mu4 as 11. So equation 3. So we have find all the moments. So I will be writing freshly here. So mu1 is equal to 0. So mu2 we got as 0. Sorry, mu2 we got mu2 is 2. Mu3 is 0 and mu4 is 11. So mu3 is 0, mu4 is equal to 11. So these are the 4 moments, and we have to find fields beta and gamma coefficients. So beta 1 is equal to mu3 square by mu2 power cube. So what is mu3? Mu3 is 0. So 0 square by mu2 power 3. What is mu2? Mu2 2 power 3, which entirely results to 0. So beta 1 is 0. So gamma 1 is equal to root of beta 1, that is root of 0, which results to 0. So this is gamma. And coming to b2, b2 is nothing but mu4 by mu2 square. That is, what did you get? mu4 is 11 by what is mu2 square is nothing but 2 power 2, that is 4. So 11 divided by 4 is equal to 11 divided by 4, 2.75. So 2.75. So beta 2 is 2.75. Let us find gamma 2 is equal to, gamma 2 is nothing but beta 2 minus 3. Beta 2 2.75 minus 3 is equal to 2.75 minus 3, 0.25 minus 0.25. So these are the values of beta 4 moments, as well as the beta 1 is equal to 0, gamma 1 is 0, beta 2 is minus 275 and gamma 2 is minus 205. This is the entire process to find the moments as well as beta and gamma coefficients. Hope you find it is easy. It's just a 5 marks question. You can solve it in a 5 to 10 minutes. Thank you.